The momentum of a system of objects. The momentum of a system of objects means that there's more than one object. So if the system contains more than one object, its total momentum is actually the vector sum of the momenta of those objects. So for instance, the momentum of the system is equal to the sum of all the momenta. That means that we add up the momentum of each particle or each object in the system, and we know that the momentum is equal to the mass times the velocity. It's critically important to note that momenta add as vectors, not as scalars. So that means if there's angles given in the problem, you need to break it up into components. We can only add I hats together and with other I hats, and we can only add J hats to J hats. We cannot add I hats to I hat, or I hats to J hats. The momentum of the system is the sum of the momenta. In order to determine the sum of the momentum, or the total momentum of the system, we first have to determine a direction to be considered positive. We usually choose that to be right. We assign positive values to momenta in that direction, and we assign negative values to momenta that are in the opposite direction. We then add the momentum of each object to get the total momentum of the system. So here's an example. Determine the momentum of a system of two objects, M1, which has a mass of 6 kilograms and a velocity of 13 meters per second going east, and M2 has a mass of 14 kilograms and a velocity of 7 meters per second going west. Again, we're going to find the momentum of the system, and remember that these are vector quantities. And that means that we need to make sure that we include direction. Go ahead and pause now and see if you can solve this. Okay, let's go ahead and take a look at the solution. The momentum of the system is equal to m1v1 plus m2v2, and again, these are vector quantities. That means that we have 6 kilograms times 13 meters per second I hat, plus 14 kilograms times negative 7 meters per second I hat. That gives us 78 kilograms meters per second I hat, plus negative 98 kilograms meters per second I hat. And that means that the total momentum of the system is negative 20 kilograms meters per second I. For this example, determine the momentum of a system of two objects, M1, that has a mass of 6 kilograms and a velocity of 20 meters per second north, and M2, that has a mass of 3 kilograms and a velocity of 20 meters per second south. Go ahead and pause the video now. Okay, let's go ahead and take a look at the answer. The mass is 6 kilograms. The velocity, let's get a vector sign on that, is equal to 20 meters per second north. We're going to use J hat for that. The mass of M2 is 3 kilograms. The velocity is negative 20 meters per second J hat. The momentum of the system is going to be mv1 plus m2v2. We're going to go ahead and substitute in our numbers, and we end up with a magnitude of 6 kilograms meters per second, and the direction is north. Okay, the next example. Determine the momentum of a system of two objects. The first has a mass of 8 kilograms and a velocity of 8 meters per second east, while the second has a mass of 5 kilograms and a velocity of 15 meters per second west. Pause the video now. Okay, let's take a look at our answers. We have the mass is 8 kilograms for M1. The velocity is 8 meters per second east. The mass of M2 is 5 kilograms, and the velocity is negative 15 meters per second. The momentum of the system is going to be the momenta of each added together. This is going to give us 64 kilograms meters per second I hat plus 75 kilograms meters per second I hat, and that's going to give us negative 11 kilograms meters per second going west. Okay, determine the momentum of a system of three objects. The first has a mass of 7 kilograms and a velocity of 23 meters per second north. The second has a mass of 9 kilograms and a velocity of 7 meters per second north. And the third has a mass of 5 kilograms and a velocity of 42 meters per second south. Go ahead and pause the video now to solve the problem. Okay, let's go ahead and take a look at the solution. We have the mass of each object and the velocity of each object. The momentum of the system is going to be the momenta of each object added together. And we're going north for the first two and south for the second, or the last one, sorry. And that gives us a total momentum, of 161 kilograms meters per second j hat plus 63 kilograms meters per second j hat minus 210 kilograms meters per second j hat, which gives us a total of 14 kilograms meters per second going north. Notice here that they do give a direction, it's north, and as long as you're writing a direction in words or using your unit vectors, this is correct. In the next video, we'll talk about conservation of momentum.